Hey everyone, how's it going? I hope that you had an awesome spring break. We're going to get back into it with the chemistry unit now, and we're going to talk about the Bohr model of the atom. So the Bohr model we use to represent, we can use it to represent the first 20 elements. You can see a picture here on the left side. So it has the nucleus here in the middle, and then we have these circles that go around the nucleus. Those are called orbits. And then these dots that are on the circles, those are the electrons. So this first orbit can have a maximum of 2 electrons. Then we can add a second orbit if we need, and that one can hold a maximum of 8 electrons. And then we can with another 8. We're not going to go too far beyond that. We're going to add a fourth orbit for a couple of elements, for potassium and calcium. But other than that, it's just good to know that it has this rule of 2, 8, 8. So what we do to make the diagram is first we have to figure out the number of electrons. So the number of electrons is the same as the number of protons, which is the same as the atomic number. So for example, hydrogen has an atomic number of 1. It has 1 electron. If you take something like chlorine, whose atomic number is 17, well, that will have 17 electrons. And then we can place the electrons in their proper orbit, remembering this 2, 8, 8 rule. So just for example, here we have helium. Now helium in its nucleus has, well, first of all, helium's atomic number is 2, which means that it has 2 protons. So in the nucleus, we can put that it has 2 protons. Helium also has an atomic mass of 4, and remember the atomic mass is the protons plus the neutrons. So if it's 4 and it has 2 protons, then we do 4 minus 2, and we can determine that it also has 2 neutrons. Now helium, again, because its atomic number is 2, that means it'll have 2 electrons. So we can put 2 electrons in this first shell. And that's because, well, it can only hold a maximum of 2. If helium had 3 electrons, then we would need a second shell. But we're going to take a look at a couple of other examples here. So neon has 10 electrons in total. Its atomic number is 10. So we can say that it has 10 protons, and it has an atomic mass of 20. So 20 minus 10 protons means that it has 10 neutrons. So we have these 2 shells. The first shell, remember, can hold a maximum of 2 electrons, so we put 2 there. Then we need to put a second shell. Now we had 10 electrons. We already used 2, so 10 minus 2 is 8 electrons left over. So we can put those 8 electrons into the second shell. Now remember, the second and the third shell can only hold a maximum of 8 electrons. So it might come up in another element. Here we have potassium. Potassium's atomic number is 19. So that means it has 19 protons and 19 electrons. So here's the diagram here. We can see that there is 19 protons in the nucleus. For potassium, its atomic mass is 39. So we can do 39 minus 19 protons to find that it has 20 neutrons. Again, because potassium's atomic number is 19, that means it also has 19 electrons. So we have our first orbit here with 2 electrons. We put a second orbit. We can put a maximum of 8 electrons there. So we've used up 10 so far, 2 plus 8. Now we need 19 in total, so we need to put a third shell. Remember that third shell can only hold a maximum of 8 too. So 1, 2, 3, 4, 5, 6, 7, 8. So we've used up 2 plus 8 is 10, plus 8 is 18, but potassium has 19, so we need to add a fourth shell for that last electron. So what does it mean to be reactive? We're going to be talking about elements according to how reactive they are. The ones that are reactive, that are more reactive, they bond easily with other elements to make compounds. So if you think back to the periodic table, the metals that were in group 1 and the nonmetals, the halogens that were in group 17, those ones were really reactive and they really react well with one another. So another thing that it means to be reactive is if the element has an incomplete valence electron level. So remember that they want a full outer shell to be stable. So for example, the potassium that we saw had one electron or one valence electron. So it wants to get rid of that valence electron because then that outer shell will go away and then that inner shell has 8 valence electrons, which is a full outer shell. So that's the basic goal of these elements. I'm just going to move my picture here. If we look at fluorine, fluorine is in the halogen group, group 17, and it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, and 7. And like we just said, it needs 8 for a full outer shell. So for example, that potassium that wants to lose its electron will react well to fluorine who wants to gain 1 electron because they both want to have 8 electrons in their outer shell. And this is true for all elements. The only exceptions are hydrogen and helium. They only want 2. Actually, you could also say that like lithium and beryllium also want to only have 2. So the first couple, they just want to end up with a full of that first shell that can only hold 2 electrons. That makes those elements stable. But for all other elements, they want to have 8 electrons in their outer energy shell. That's called the octet rule. So these will keep bonding until their outer shell level is complete. So if they only have a few valence electrons, so the ones that only have like 1 or 2, they want to lose those. But ones with 6 or 7, they want to gain those electrons so that they end up with 8 valence electrons, and that way they'll be stable. We're going to take a little closer look at Bohr models and reactivity in a future lesson. But for now, that's it for today. Hope you all have a good day, and I'll talk to you guys soon. Bye.